Hi, this is Shivani Madam. Our project name is Sign Language Recognition. We are a team of 4 people. These are the contents we are going to discuss. The goal of the project, what we have learned, and what needs to be achieved. Here, the motivation. The purpose of the research is to create a network that could recognize which communication of the American Sign Language character set was being written from a picture of writing hand. The first step of the research is coming up with a sign language decoder that can take sign language messages and convert them into transcribed and verbal language. The translator will be an advantage to the deaf and mute people since it would make it easier for them to interact with other people in their daily lives. This aim is further fueled by the sense of isolation that exists among the deaf population. Loneliness and sadness are more common among the deaf community, particularly when they are entrenched in a hearing culture. The communication gap between the deaf and the hearing creates significant hurdles that have a significant impact on living quality. Information deprivation, a lack of social relationships, and trouble integrating into society are just few examples. Significance. The majority of the research solutions for this job have relied on depth maps and high resolution pictures obtained by a depth camera. The goal for this experiment was to test if neural networks could characterize signed ASL letters from basic hand photographs captured using an individual device like a laptop cam. This remains in line with the inspiration since it would allow us to real-time ASL to oral transcript language decoder. We need to develop systems that recognize the different signs and convey the information to the normal people. The objectives. The main objective of the project is our research strives to close the gap between the person with speech and hearing impairments with the general population. The main goal of this project is to generate a system that permits deaf people to converse successfully with others by utilizing their normal signs. The background does not have to be completely black for the system to work. It looks good against any background. The project employs as an image processing scheme to recognize mainly English sequence sign language that is used by the deaf to converse and translates it in writing that can be acknowledged by non-deaf persons. Features. Data processing. This is where the data is loaded. The raw picture data is loaded into the PyScript and the image data is kept as NumPy arrays within the file storage. The process data.py script heaps picture data after data.npy and pre-process it by rescaling it, putting in filters and ZCA failing to improve features. The picture data was divided towards exercising authentication challenging data and returned to loading during training. A load dataset.py script is also used during training, which loads the required data into dataset class. A separate image is imported and managed from the disk for usage with the qualified model in the categorizing signs. Before getting into implementation, we made some analysis on different approaches that could be possible. For that, we as a team did research in 4 different directions possible and figured out 4 different ways. And as a team, we debriefed those approaches and discussed the pros and cons of each approach. And we were decided with one approach as a team decision. Now we individually going to different approaches and research work we did. Coming to my approach, I'm going to explain hand gesture recognition based on digital image processing using MATLAB. Here, the American Sign Language is used for the deaf people in which communication is done in the form of symbols with the help of hands without using sign. ASL is the world's third most widely used sign language, as shown in the figure. This is the ASL standard language. In the digital image processing approach, we recognize gestures taken from the camera and convert them into text and speech. Here, images taken from the camera and pre-processing of images done. Apart from the light, background, focus of the camera and duration affect the result. Actually, this digital image processing is done in different ways like skin detection, image filtering, and image segmentation. The main approach of digital image processing is to be used in real life without any hardware equipment. Here, we can see the implementation. Here, first we can take the image of gesture by using a proper film with specified boundaries. For the image, we use linear image filtering enhancements like smoothing and edge enhancement. Color segmentation. For image refining, we here use the gray world algorithm. And if you see here, there are a few techniques for the skin detection, like it is CIXYZ, YCBCR, YEQ, YUV. Among all these 4 detection process, I have chosen YCBCR as a skin detection algorithm. In YCBCR color space, Y represents the newness information, CV is the difference between blue component and the reference value, and CR is the difference between the red component and the reference value. If you see that how it works, here we capture the image and note down all the dimensions of the image. We eliminate all the noise in the image. Next, we apply the gray world algorithm over the image. It converts RGB into YSFR component, which helps to identify skin and non-skin elements. After detecting the skin, wherever we have the skin part, we mark it as a blue color, as seen in the image. If you see, this is the original image. Where it is skin, we detect it has a blue colored sketch. Then later we detect has a recognition. So this is digital image processing. The other approach will be explained by Navyashri. Over to Navya.
Yeah, hi, this is Navyashri. I'm going to explain the like, I'm going to explain the image processing approach. It's a collection of algorithms for evaluating, improving, and compressing the images. The images are taken through scanning a digital photography, and this is used in various applications, including medicine, sign language, industrial robots, astronomy. And here, the basic motto of this is to recognize the patterns. And through this architecture, next slide. Uh, Through this architecture, I'm going to explain the whole process of the approach. Mm, in first, the image is taken from the image through photo from computer, and then the image is taken in color like red, green, or blue, and then it is converted to grayscale conversion, uh, where the primary colors are red, blue, and green, and based on the lens of the camera or the intensity of the color, the image is recognized. After recognizing that, the according to the symbol shown in the image, you have to choose the portion of it, and the pattern is displayed it to the according to the colors of the symbols. From then, the picture is going to be converted into black and white, where the symbol is going to highlight with white and the background would be black. Uh, and then this is the all comes under module 2 of image processing. Then we're going to pattern the matching the pattern which we have found in the image. If we found the pattern which is already in database, that's gonna display like that's gonna convert the audio into text and display it in the image. And this is about the image processing approach. And next, Niharika will explain.
Yeah, hi, I'm Niharika. I'll be explaining CNN, neural network. It is one of the approach we studied in this project. First of all, I'll be explaining why CNN, like computer vision based hand gesture detection is one of the most popular human computer interaction technique. Here, skin detection, hand segmentation, hand motion tracking or the processes which are implemented. But in real life, it is very difficult to uh, get something which is like variable, which is having variable lightning or skin color because of ethnicity, everything. To address all this, here CNN comes into picture. CNN is the deep learning techniques which uses visual context, which visual context is nothing but the fundamental block of the human vision. CNN, CNN has the major or a major of convolution and pooling. In fact, convolution is one of the process which is used by the human brain to understand the digital picture or the picture which is visualized by a human eye. Here in CNN, we have three layers, which are convolution layer, pooling layer, and full connected layer. Next slide, please. Yeah, in convolution layer, the first image is scanned for the main key features. The filters are applied to extract the main features in the image. Here, a small kernels or the small grids are applied to study the image. And in one filter or a grid, we can zoom or we can feature out only one object. Coming to pooling. Here, pooling is nothing but the shrinking of the image size. By shrinking the image size and lowering the size of the picture, which are the pixels, we can study the we can study that deep pictures or the other small objectives here. Yeah, coming to the third layer, which is fully connected layer. In fully connected layer, here it shows the output of the both layer in the required format. Yeah, thank you. I'm handing to Meghana.
Yeah, hello, I'm Meghna. So as my teammates already discussed about the different approaches to build the sign language, we have finally decided to go with the OpenCV and NumPy using Python libraries because it is more efficient when compared to the other approaches in terms of cost and then time. When coming to the first one, this OpenCV. This OpenCV stands for Open Source Computer Vision. It is mainly focused on real-time computer vision. So it's basically useful for the image processing, and then it does operation related to the images. To install this, we need to first install the any Python platform, and then we need to use the following command, which is pip install opencv python. So once the command is entered, then it will fetch all the packages required for that, and then it will be downloaded into our system. Once it is done, we'll go with NumPy. Shivani, can you please move? Yeah. So this NumPy stands for numerical Python, and this mainly open source library in Python, which performs mathematical numerical calculations and computation. It is mainly used for array of applications like array manipulations and array generation. We can easily generate arrays with random values and reshape the arrays. So for the installation of this, we'll use this pip install numpy command. So once this is done, it will fetch all the required libraries to our Python. And after that, we'll go with the Pygame. So this Pygame is a cross-platform set of Python modules designed for the writing video games. It mainly uses for computer graphics and sound libraries designed to be used with the Python. Actually, we can also use this to run the different platforms and then operating systems. To install this, we'll use this command. We'll use this command pip install pygame, and then the required packages will be downloaded. After that, we'll go with the Tincter. Because Tincter is a part of Python standard library, which provides an object-oriented interface onto Tincter. This enables the developer to build a cross-platform GUI for Python applications without needing further dependencies. To install the Tincter, we'll use this command pip install tk. So once this is done, we'll be creating a window for the application. So for the window, we have used this root Python window, and then we'll be creating labels and buttons. Shivani, can you move to the next slide?
Yeah.
So this is the code we have used for the window. So once the window is created, we have created 3 buttons, that is instructions, and then run, and then exit. So this is the page, this is the window page. So if the user wants to listen to the instructions, he can click on the instructions. Then all the instructions will be visible for him. If he wants to start the application, he will just click on the run, and then he can use it. If he wants to exit, he'll click on the exit button. So this is the input file we have given for the program. So these are all the alphabets, because the sign language mainly focuses on the alphabet. If the person shows some sign in front of the webcam, it captures the image, and then it will compare with this input. So this is the output files. So the output will be in the text format and then MP3 format. If the person is unable to hear, then sound will come. So he can easily listen to that sound and then identify that letters. So this is the code we have written for the every alphabet. So this is the sample code for the text A letter. Usually as there are 26 letters, we have divided this into among ourselves, and then we have created 10 to 15 letters. So remaining letters needs to be done. Coming to the implementation status, 75% of the project is already completed, and it shows us some desired results as well, such as detecting the hand signs of some alphabets via webcam and displaying the desired results. A few more alphabet logic needs to be analyzed and work on the implementation. Coming to the task performed. So before implementing the code there will be so much of background work that takes place, right? So first we have collected inputs from the various sources. Once we have collected, we have analyzed different approaches, because as everyone in our team went with one approach, so we have discussed so many times, and finally we went through this OpenCV and NumPy approach. After that, we have started implementing the code. We have divided among ourselves, and then after every one code is developed, like for every letter, if the code is developed, we are testing that. So once it is done, we are preparing the documentation. Shivani, next slide, please. So coming to this future works, as I have already told that 11 alphabets are remaining. So we are working on that, and unit testing and integration testing needs to be performed, because unit testing is already completed for 15 alphabets like that. And the integration testing, once all the alphabets are completed, we'll integrate that to the code, and then we'll test as a whole. The future scope is like, now we are just giving the input sign and then the letter is coming, but by using facial expressions, it will be very good if we can expand this project to the facial expressions. And also now only one letter is coming, like if we show that symbol, only A will be displayed. But if some text like sentence, if it is be displayed like that, then it would be great for the people who uses this application. So the software process models will be explained by the Niharika.
Yeah. In software process model, we have followed the incremental model for our development, as we do our project in increments. In first increment, in part of communication, we among ourselves has communicated what to do, and we also known from the user point of view, like the basic questions: what are the problems faced by the speech and hearing impaired people, and what are the most used signs over here, and what the usual mistakes made by the existing systems, and what are the methods which are mostly used by the users. In planning, we made analysis and done prioritization of the requirements and what to do in the first sprint and what to do in the second sprint. And we divided work among ourselves. And in modeling, like what are the design of the screen which we have to make, we analyzed that and we made the model for that. And coming to the coding section, we considered Python and OpenCV, as Megha told earlier. And we have also done the unit testing, which is for only recognizing the alphabets. And we have to do integration testing and some parts of the testing in the future upcoming planning. And coming to more model, we have followed the agile model. In agile model, like basically we'll be having a meetings, right? Backlog refinement, sprint planning, coding testing, and daily scrum meetings and sprint reviews. These are all meetings which we conducted or followed. Like in backlog refinement, we usually talked about what are the approaches, the 4 approaches which we followed and which one is the best one we have to proceed with. And in sprint planning, also we discussed and divided the work among ourselves, which we conducted before we starting the project. And in daily scrum meetings in our project is nothing but the calls which we have on discussing about what work you have done, and do you need any help from other, or are you okay? These are the questions which we asked for our daily meetings, which are daily scrum meetings. And in sprint reviews is nothing but in our project, like the demo, showing to each other what the work we have done, taking the feedback from from each other and putting our points and explaining what are the benefits or the points which we have to get. Yeah, thank you. Next slide. Yeah, these are the contributions which we made to our project. Next slide. Thank you.